We continue our neetcode session, and today we are going through, and so let's check our dashboard, 2 pointers, and let's take the next task. So the next task calls toSum. To input array is sorted. So we are given an input array that already sorted in non-decreasing order. We should find two numbers such that they add up to specific target number. Let this two number be number 1, number 2. Okay, and we should return the indexes of two numbers, each incremented by 1 as an integer arrays of length 2. Okay, the tests are generated such that there is exactly one solution. You may not use the same element twice. Your solution might use only constant extra space. Right, so we cannot actually use here hash map as we used before, and so the main difference that it's previously sorted. So let's take a look. So we have an array that is sorted, and our task is to return two indexes, index 1 and index 2, of sum that would be equal to k. So let's take some examples. So we have 1, 2, 4, 5, and for example, and 5. Let's say we have k equal to 5. In this case, we should return 1 and 3 because 0 and second index. Okay, I understood. So if we can't use extra space, what we can do? Well, let's check approaches that we can use here. So the first approach is actually use two loops and check for each number by checking all others. So we have n squared time complexity here with space complexity constant, and let's call it two loops. But if we have constraint, for example, our array length is less than or equal 10 in, let's say, even 5, so it would be quite big for us. And here we have 10 in 4 power, so it's also quite big. So quadratic time would not work here. So we need something that we will use maybe 2 pointers, right? If this value is sorted, so maybe we can use 2 pointers here. I was thinking about binary search, but what if we have just 2 pointers from right and left? So let's say that we have pointer from right and left, and we, for example, here we have sum that is greater than k, then we move this pointer. If it's less, then we move this pointer. So I think it should work. And here's the solution. It's linear. So let's try to implement it. So we have 0, and we have numbers length -1, and while j minus I is greater than 0, we actually do this check, and here we return null. And here we check if numbers, let's call it array, I think it would be faster. So if array on index I plus array on the index j is equal to target, then we just return new int I plus 1 and j plus 1. Otherwise, we check. So if this sum is greater than target, then it means that we need to move our j else we need to move our A. So let's check. Yeah, we see that it accepted, so let's submit. And we submitted, and we see it's 96%. We don't have, we have previously submitted. Okay, how we submitted? So yeah, so we have the same submission of 1 year ago with 2 pointers. Here again, 2 pointers. Let's check here. Here we have hash map, and here quite complex. Yeah, and here, yeah, so 2 pointers. So yeah, so we see that it's actually 2 pointer solution and nothing more interesting here. So we can just mark it as done. So let's go to sums, so 3 sums. So 3 sums, it's actually a classic problem where we have numbers, right? Number array, and our task is to find 3 indexes, right? That is equal to 0. And here we should find all possible solutions where we add 3 values. We should return all of them. So for example, -1 and -1 plus 2, it would be equal to 0. Then -1, 0, and 1, it also would be equal to 0. So we have to find all 3 sum values. So how to do it faster? So faster it would be like this. So we first sort this array, and then we iterate over this value, and then we have 2 pointers from right and left, and we try to find such sum that is equal to 0, and if it find, we just add to the result list. So let's try to implement this. So we have result. I'm not going through the whole framework that we have because it's quite famous problem, and we just need to implement it, and that's it. So we sort this array, then we go through, I think we even can take value from here. Then we, I think that we cannot do this because we need I plus 1. So we start from the first value, then we go to nums lengths, and then in here we have j. Let's do the following. So here we have int j that is equal I plus 1, and k that is equal nums lengths minus 1. So we have both operations. And we have here 3 if blocks. So first it would be when nums j plus nums k plus we can plus here nums I plus all this thing. If they equal to 0, then we add to our result a list of all these 3 values. Else if this sum is greater than 0, then we need to move our j pointer. Else we need to move our I pointer, and this one we should do in the loop while chi minus j is greater than 0. Yeah, and here we should do like K and J. Yeah, and here we just return our result. Let's make it formatted. And let's run. Memory limit. Let's take a look. What's the problem here? So we have J and we have K. And here, of course, we need to do like K plus K minus 1 and J plus 1. Yeah, so here we see that we have like two same values, but we don't need to have the same values. So I propose what I propose here. Yeah, the simplest would be to store them in the set, like not this one, but set, right? Then we have result. Result add to the set of, but this result is incorrect, so we need to iterate on, yeah, to have another result. List of lists, let's say, res2. Yeah, it looks ugly, so we add all. Here it would be set of integer, set of integer in result, and all here, result 2, result 2. Set can be converted to collection. What if we do like this? I think it should be something like this. No? Let's think, what can we do? Maybe we can do like this. So let's have it as result. And let's have another set of strings visited hash set. And here, when we find something, we also add to our visited. Yeah, so we not add like if visited contains if it not contains. So we first create a key, string key, and key would be the following. So we just add all these numbers and we create some kind of this one. Yeah, so it would be key. So if it not contains, and here we just add this key. Okay, so result add here should be list. Yeah, so it's accepted. Let's submit. Yeah, and we are done, but I believe that we done not optimal. So what's the difference between this one? So we still sort, right? So we iterate, then we have, yeah, we have this kind of things, and is equal, we add to our result. Okay. Yeah, it's something different. Here, yeah, we have visited, so it's kind of look like the same. Let's check edit as editorial. Okay, let's check our submission, and let's check here what we have the most useful. So we have list, sorted, the same, yeah, the same logic. Sort. So they just sort differently. And merge, so they use merge sort here. Okay. Yeah, look like the same. Okay, so we can, I think we can set it as done. So let's go to the for sum. What's the difference between for sum, we're given an array of nums. We have returned all unique quadrilaterals that should be equal to target. So I believe that, yeah, we can actually reuse this logic. We can reuse this logic. So yeah, just copy this thing, and we still sort these numbers, right? And also we have visited. And here what we need to do, we have just two iterations. So j, it would be I plus 1. J is less than nums length. J plus plus. So we have two loops. And then internal loop, I believe we can reuse this logic here. And here it would be not j, but it would be k, j plus 1. Then instead of k, we have, for example, f, right? We have f. And while f minus k is greater than 0, here we check three things: I, j, k, and nums f. And here also we have another nums f. And here we have also nums f. Yeah, and here k and f. No, here it will be f, and here k. Visited key, okay. Here nums f, and if it's greater, then we decrement f, and here we increment k. And let's format our code and let's submit. So it's not, it should be equal to target, and target yeah, accepted. Let's submit. So we have a wrong answer here, and wrong answer because we have integers. We have integers. Yeah, so the problem here is we need actually long and not integer, and in this case, Yeah, in this case, we calculate just this sum as long. Let's call it sum. So we calculate all this integer into long. And here we compare with target. And here we, yeah, also here sum. Check. Use case, check. Check. How many? 3, 3, 3. Yeah, so when we, for example, had here it was 2. So in this case, yeah, I believe we need some kind of long casting. And then submit. Yeah, so it looks like ugly casting, but let's check. Yeah, so we see that we still need this long thing, and we still need sort, so we still need 2 loops, we need 2 arrays, we have while. Yeah, so looks like the same that we have previously, so we can just mark it as done. And yeah, so I think that's all for today. See you tomorrow.